So I want to do a few more examples here. Sometimes we're not always looking for the area to the left. So a lot of times we're looking for the cumulative area, but not always. Sometimes we want the area to the right. Sometimes we want the area between two z-scores. So how can we find those values? And then here's just some guideline as well. So the pictures I think are really helpful. I always draw my pictures when I'm doing this section of the text. I really do. I just think it's so much easier to visually see what region I'm looking for. That helps me find my cutoff values and know what I'm trying to find. So when you're looking for the area on the left, or that cumulative area, okay, so this is area to the left. You may hear it as cumulative area. You may see the symbol as less than or equal to, so we're looking for some value smaller. Your picture is going to look like this. So we've already done these examples, right? We can use our technology, or we can use that table right in the book, and it's going to give us this value. Sometimes we don't want that area, though. We want other areas. So when you see this, you'll sometimes hear this referred to as area to the right, or you may notice symbols like greater than or equal to. So when we're doing this on technology, it's the same steps. So we just give our lower bound and our upper bound. So here our upper bound would be positive 9999999 instead, but it's the same process with technology. In the table, it's different though. So your table only gives you values to the left, only. So if you want the value to the right, what you have to do is take that table and subtract it with 1, because the whole area under the curve is 1. So if I know this area, I can subtract it to find the other area. So again, I'm going to show you an example, and we'll do it on technology. Technology, I think, is much easier here. It's very straightforward. The steps don't change. But if you're using the table and you want the area on the right, you have to subtract with 1, because we really want the complement. That's what we're looking for. And the last thing you would see here is an area between two z-scores. So you may see wording like between. You may see symbols as well. So you could see something like wording like in between, or you may see something like, I don't know, here's one z-score to another z-score. So maybe we're looking for the value from -2 to 4 or something like that. So if you have something in between, then you're going in between the two values. With technology, this is pretty straightforward. It's the same process. We just give our lower and our upper bound to the calculator, and it computes it for us. With the table, it's a little bit weird. So what you have to do with the table is find the area for each z-score in the table. So you find the area for this one and the area for this one, and then you subtract the two areas, and that's how you get the area in between. Okay, and again, I'm going to show you an example of each type. All right, so we're going to find the area under the standard normal curve. So if you see standard normal curve, then your mean is 0 and your standard deviation is 1. Always, always, always. Okay, so if you see that word standard. Okay, and we want the area to the left of the z-score. So the first thing I'm going to do is I'm going to go ahead and draw this picture in. It doesn't have to be perfect. So my center here is at 0. Oh, this is not focusing, hang on. All right. My z-score is a negative, so it's going to be to the left. It's negative 0.99. So again, I'm just going to estimate it. It doesn't have to be perfect. Okay, so this is my cutoff right here for my z-score. And I want the area to the left. So again, I like to just shade in what I'm trying to find. It helps me stay focused. So that's what I'm looking for here. All right, let's use technology first. So for technology, we're going to hit that second key, and then we're going to hit bars. second key and then bars, and you're going to hit normal CDF. All right, so again, we're doing second, bars, and then normal CDF. And what you do is you always put in first your lower bound. So notice that there is no lower bound, right? It keeps going left. So we're going to use negative 99999. And then you put in your upper bound. So where does the shading end on the right? It ends at negative 0.99. And then, oops, I forgot my comma, hang on. Comma, negative 0.99. So I want to make sure I put commas in between all these values, comma. And then we put our mean and our standard deviation. So I'm going to do 0, 1. And when I get that, I get about 0.16107. And again, using just 4 decimal places, I'll get 1611. So we enter our lower bound first for the shaded region, our upper bound for the shaded region, our mean, and our standard deviation. All right, let's use the table. All right, sorry, I closed it. Let me get it back out. So we have negatives here. Okay. So I'm looking for negative 0.99. So negative 0.9 is my first piece. So I'm going down here to negative 0.9. And then I also want my second value to be 9 as well. So my hundredths place is 9, and then I'm at negative 0.9. So when I match those up, that column up with that table, I get 0.1611. And that was the value that we got here with technology. So right there, 0.1611. So when you're finding area to the left, it's pretty straightforward with the tables. Whatever value is given there, you're just going to go ahead and take. All right, let's find the next one. Find the area under the standard normal curve to the right of the z-score. And again, I see standard normal, so I know my mean is 0 and my standard deviation is 1. That's kind of a lousy picture, but you guys get it, right? So my z is positive, it's going to be to the right. It's not too far, it's only 1. So right here. And then I want the area to the right. So I'm looking for this area. Okay. So using technology, we're going to start the same way. We're going to hit that second bars button. We're going to hit normal CDF. Now, we always do it in this order. Lower bound first, just like this one, then upper bound, mean, and sigma. Okay, so my lower bound here, so look at your shading. My lower bound is at 1.06. That's the smallest value that I'm shading at. So my lower bound here is going to be different. It's going to be 1.06. Now, I keep shading to the right, and that keeps going forever. It's not stopping. So I'm just going to use positive 99999. It just gives me a large number, so just use any really big number. My mean is 0, and my standard deviation is 1. So that's how I'm going to enter it on my calculator. So second, bars, normal CDF. My lower limit is 1.06. Don't forget those commas in between. My upper limit is positive 99999. Again, it doesn't matter really how many nines you add, just add a bunch of them. 0 for my mean, 1 for my standard deviation, and I hit enter. And I get about 0.14457, so about 0.1446 if we round to 4 decimal places. So notice that with technology, the process doesn't change here, which is why I kind of tend to like technology better, because I just always do lower bound, upper bound, mean, sigma. That's it. And it will always give you that area for you. Now, if you're using the table, let me show you how that's. so here's my table. And remember, we're looking for a z-score of 1.06. So notice I'm on the positive table right now. So there's a negative table, there's a positive table. So I want you to notice too, in the table, it's always the area on the left shaded in. Your table does not give you area to the right. It does not give you area between values. It only gives you area to the left. So when I find that value, I need to remember that I'm not getting the answer I want here. I'm getting the area to the left. So I want, what is that, 1.06. All right, so I find 1.0, and then my 6 is over here, so I'm going to match those up. Let's see, what do I get? I get 0.8554. Okay, so I'm going to write this down, 0.8554. So I want you to remember that in the table, right, this is what the table gives you. Here's my 0. Here's my z equals 1.06. What your table gives you is this side, okay? So your table doesn't give you the right, it always gives you the left. We want this side though. This is what I want. So what we do is we subtract with 1. So I'm going to do 1 minus 0.8554. And you can use your calculator here, or you can do it out by hand, whatever you prefer. And I get 0.1446. So same answer, just a different way to go about getting that result, right? So again, just be careful with that table. It's always area to the left. So you may need to do some tweaking to get the area that you want. All right, let's do one last example. Find the area under the standard normal curve. So mean is 0, sigma is 1, between 2 points. So now I'm going between two z values here. All right, so I'm going to draw my picture first. Again, my center is at 0. All right, so I have one z value that's negative. Okay, so it's going to be like around right here, 1.5. And I have one z value that's positive. So again, this is not perfectly done to scale, but you can get a close enough idea. And I want the value in between. So what I want now is I want this region. So this whole thing in between here is what I'm looking for. Now, if you're using technology, it's the same steps. So this is why I like technology, because it's always the same steps. It doesn't matter what the graph looks like. I just plug in my values and it finds it for me. So here, my lower bound is going to be negative 1.5. It's not negative infinity because I'm stopping, right? My lowest value I'm shading in is negative 1.5. My upper value is 1.25. And again, it's not positive infinity. It's not going to the 9s because I'm stopping at 1.25. My mean is 0 and my standard deviation is 1. All right, so let's plug this all in. Okay. So I hit second bars. I do my normal CDF. My lower bound is negative 1.5. My upper bound is 1.25. My mean is 0. My standard deviation is 1. I hit enter and I get about 0.827543. So 8275 if I'm rounding to 4 decimal places. And that's the answer. So if we're doing technology, we're done. If we're not doing technology, though, we can use the table. So I just want to draw a picture here too as well, kind of see what you're getting. So z equals negative 1.5 equals 1.2. All right, so I just want to have my values there so I can kind of write everything down on the table. All right, so let's go back to my table. So my first one is my negative. My goodness, book is giant. All right, So it's at negative 1.5 and or be negative 1.5 0, right? So there's no value afterwards. So negative 1.5 is right here. And then if I want a 0 at the end, I'm just going to go all the way over. And I see that value is 0.0668. So I'm going to write this down. Again, I'm lining up and finding that negative 1.5 going over to 0. And I get 0.0668. Now remember that this is the area to the left of the z-score. Okay, so this value here, I'm going to get 0.0668. And what I'm getting there is this area right here. So I'm getting that area to the left. There we go. Now I got to find the other one. So I want z equals 1.25. So I find 1.2 first. And then my other value is 5. So I'm going to match those up. And I get 0.8944. Let's use orange here. Now, what am I getting? Now, when you use the table, I'm getting this. Okay, so it's everything to the left, including the green part. So it's the whole thing to the left. So when you want the area in between, what you're going to do is take the bigger value, so that 0.8944, and subtract the smaller value. And that will basically give you this whole area, and then we're minusing out the green. So it's going to end up minusing or subtracting this piece away and give you that center value that you need. So when you're doing in between, you're subtracting the two values from the table. And when I do that, I get 0.827, 6 here. Okay. So just about the same value, right? It's a little off because of rounding error. The technology value is actually more accurate. The reason we're a little off here is because these two values are both rounded already. So when we subtract, you have a little bit of error in there. Whereas here, we're rounding at the very end, which is always the best way to do it. But they're both correct. So they would both be acceptable answers and should both be marked correct, whether you're using the table or technology. So those are the three main ways that we're going to find our areas when dealing with the normal curve. So either you're going to see some sort of area to the left, some sort of area to the right, or some sort of area in between. And you can use whatever technique you want. If you like the table, feel free to use the table. Just be careful and make sure you're using the right format for the other two forms. If you're using technology, it's always the same setup. So you just want to input your values, obviously correct, in the correct way.